Welcome to CodeTether Radio, the show about autonomous software development, agent to agent systems, and the future of AI engineering tools. In this first episode, we are introducing CodeTether Agent, an A2A-native AI coding agent built to move beyond simple autocomplete and into real end-to-end software delivery. Most coding assistants wait for a developer to ask the next question. CodeTether is designed around a different idea. The agent should understand a goal, inspect the codebase, plan work, use tools, run checks, delegate subtasks, preserve context, and keep moving until the work is actually complete. The core workflow starts with ordinary development tasks: fixing bugs, adding features, refactoring modules, writing tests, updating documentation, and reviewing pull requests. But underneath that familiar surface, CodeTether has a much broader architecture. It includes a tool system for file operations, shell execution, code search, language server navigation, web access, media generation, browser automation, Kubernetes management, and persistent session memory. It can run as a terminal user interface, as a command line agent, as an MCP server, or as an A2A worker connected to a broader agent network. One of the most important pieces is Ralph CodeTether's PRD-driven autonomous development loop. Ralph takes a product requirements document, breaks it into user stories, works through those stories in fresh iterations, records progress, runs quality checks, and updates the PRD as stories pass. The point is not to replace engineering judgment. The point is to make the repetitive implementation loop faster, more traceable, and easier to supervise. Another major piece is the Recursive Language Model system, or RLM. Large codebases do not fit cleanly into one model context window. RLM lets CodeTether search, chunk, analyze, and synthesize information across large repositories and large session histories. When an agent needs to understand a sprawling module, a long transcript, or a complex design document, RLM gives it a structured way to reason over the whole thing instead of guessing from a small excerpt. CodeTether also supports swarm execution. A single agent can be useful, but many software tasks split naturally into independent workstreams. One agent can inspect backend changes, another can test UI behavior, another can review documentation, and another can check policy or security concerns. Swarm execution lets those focused agents run in parallel and aggregate their results. The project is built in Rust with a strong emphasis on performance, reliability, and explicit structure. The goal is not only to make an AI coding agent, but to make one that can be installed, audited, extended, deployed, and trusted inside real development workflows. So CodeTether's architecture includes provider abstraction for multiple model backends, vault-back secret management, mandatory authentication for server routes, audit logging, policy enforcement, MCP integration, Kubernetes deployment management, and Worktree isolation for safer autonomous changes. That Worktree isolation matters. When an autonomous agent edits code, it should not casually mutate a developer's main checkout. CodeTether can use isolated Git worktrees so experiments, PR fixes, and autonomous implementation loops happen in a contained branch. That makes it easier to review changes, roll back mistakes, and merge only what is ready. The tool system is another central idea. A model by itself only predicts text. A useful software agent needs grounded actions: reading files, editing code, running commands, searching references, checking diagnostics, opening browser pages, and calling APIs. CodeTether exposes those capabilities as structured tools so the agent can act, observe results, and adapt. This is also why MCP support is important. MCP, the Model Context Protocol, gives tools and resources a standard interface. CodeTether can expose its own built-in tools through MCP and connect to other MCP servers. That makes it possible to bridge local development environments, external services, and specialized toolchains without hardwiring everything into one monolith. The A2A angle is about collaboration between agents. In a future software organization, there may not be one assistant sitting next to one developer. There may be many agents: a reviewer, a tester, a release manager, a documentation writer, a security auditor, a customer support triage agent, and a planning agent. A2A gives those agents a protocol for communicating tasks, status, and results. CodeTether is being built with that future in mind. It can run locally, but it can also participate as a worker in a larger agent network that opens the door to distributed execution. One central system can assign work to many specialized workers, each with its own codebase access and policy controls. A practical example might look like this. A developer says, implement a new authentication feature. CodeTether inspects the project, finds the relevant routes, models, tests, and documentation, drafts a plan, edits the necessary files, runs targeted checks, fixes errors, and prepares a summary. If the task is broad, it can delegate parts of the investigation to sub-agents. If the implementation requires a PRD, Ralph can execute the user stories one by one. The value is not just speed, it is continuity. Traditional chat sessions lose track of what happened. CodeTether persists sessions, records tasks, supports context browsing, and can recall prior decisions. That matters because real engineering work is not a single prompt. It is a chain of decisions, constraints, failed attempts, fixes, and validation steps. There is also an emphasis on code quality rules. In this repository, agents are expected to respect single responsibility, modular cohesion, file size limits, documentation standards, and project specific instructions. That is a key lesson for AI assisted development. Agents should not just produce code that compiles, they should follow the local engineering culture of the project. For open source users, CodeTether is meant to be understandable and extensible. New tools can be added by implementing a tool trait with a schema and an execute function. Providers can be added behind a common provider interface. The project documents patterns for tests, Rust doc examples, security modules, and deployment. Looking ahead, the interesting question is not whether AI agents can write code. They can. The harder question is whether they can participate in a disciplined software process, understanding requirements, making small reviewable changes, keeping audit trails, handling secrets safely, respecting policy, and knowing when to ask for help. That is the space CodeTether is exploring. In future episodes, we will go deeper into Ralph RLM, MCP integration, swarm execution, Kubernetes worker deployment, and the design trade offs of building an autonomous coding agent in Rust. For now, the big idea is simple. CodeTether is a coding agent designed for real workflows, not just demos. It combines language models with tools, memory policies, work trees, and agent to agent protocols so software work can become more autonomous while still staying observable and reviewable. Thanks for listening to CodeTether Radio.